In the first part of section 1.5, we learned how to rewrite expressions with absolute values without the absolute value sign. So we removed the absolute value sign. In today's lesson, we are going to continue studying absolute value, but we're going to learn how to solve absolute value equations and absolute value inequalities. Example 1, we're asked to solve this equation, and you did these kinds of equations back in pre-calc 20, I believe. So again, absolute value has two branches, so we're going to go 9 minus 5x is equal to 6, or 9 minus 5x is equal to negative 6. So now I'm going to subtract 9 over to the other side, and I'm going to divide by negative 5 to get 3/5. And then I'm going to subtract 9 again over to the other side, and this time I am going to get negative 15. And I'm going to divide, and I'm going to get 3. Now, you must verify that both of these solutions are valid, and we always verify back in the original. So the absolute value of 9 minus 5 times 3/5, is that equal to 6? Well, 5 times 3/5 is 3, 9 minus 3, and we know that that's going to equal, so that is valid. And if we look at the next one to verify, I'm going to have the absolute value of 9 minus 5 times 3. Does that equal 6? So I'm going to get 9 minus 15. Sorry, it should be the minus 15. Does that equal 6? Well, we know that this left side is the absolute of negative 6, and that does equal 6, so they're both valid. So these two solutions are valid. Now, some books will show you to negate, use the positive 6 and negative 6, and others will plus or minus the absolute value. It really doesn't matter. You'll get the same solution either way. So in this particular case, we'll do it the second way I talked about. So let's say that we are asked to, I'm just going to make this pen a little bigger. We're going to say we have the negative of, sorry, we're going to have the positive of 15 minus 2t equals t plus 6, or, and I need to make this pen smaller, sorry, it's going to be the negative of 15 minus 2t is equal to t plus 6. So in this first equation, I'm going to subtract the t over to get negative 3t, and I'm going to subtract the 15 over to get negative 9. Divide by negative 3, t is going to equal 3. And in this second equation, when I distribute the negative sign, I get the following, and if I subtract, I get t equals, if I add 15 over to their side, 21. And again, I must verify both of these. Again, we verify in the original, so 15 minus 2 times 3, does that equal 3 plus 6? Well, 15 minus 6 is the absolute value of 9, and that does equal 9, so that's valid. And again, for the second one, 15 minus 2 times 21, does that equal 21 plus 6? Well, this becomes 15 minus 42. This works on the right-hand side to be 27, and 15 minus 42 is going to be negative 27, and we know if we take the absolute value, that's going to equal 27, so that too is valid. So when we're solving absolute equations, we actually get solutions, two solutions, maybe one solution, depending if it's valid. And now we're going to look at solving absolute inequalities. Now, when we solve inequalities, our textbook suggests a couple of ways to do these. There is more than one way that you can do these types of problems, but I will follow the textbook for the first couple of examples. But then for the more complicated ones, I'm going to show you a way that I think is easier than what the textbook shows us. And first of all, if we have, these are the two rules. If you have the absolute value of something, and this absolute value is less than or equal to b, so basically what we do then is we would say negative b is going to be less than or equal to whatever my star is, less than or equal to positive b. So this example would follow that rule. So I am going to write negative 5x plus 4, that's my expression inside the absolute value signs, is going to be greater than or equal to negative 11, which is going to be less than or equal to positive 11. And now we're back to what we did in section 1.4 in solving inequalities. So I'm going to subtract 4 from both sides to get negative 15 is less than or equal to negative 5x is less than or equal to 7. And then I am going to divide both sides by negative, or both sides of the inequality by negative 5. So I'm going to get 3. When I divide by negative 5, it's going to flip my inequality sign. And this is going to be negative 7/5. Again, if I write this in proper order, it's going to look like that. And in an interval notation, my solution would be negative 7/5 to 3. So now when we're solving inequalities, we get an interval of values, not just specific values. Okay, in our second example, this one here is a little bit more challenging. And before I do this one, I'm just going to do one more. Okay, and this one, let's take a look at if our question was, just give me a second to find one. So let's say we have the absolute value of 6 minus 5x is greater than 21. Now, notice in the first example, we had it less than or equal to a constant. And in this second example, it is greater than 21. So we're going to follow another inequality rule that says if I have the absolute value of some star being greater than 21, then the two cases are going to be the star is greater than 21 or the star, whatever's inside the absolute values, is less than negative 21. Okay, so in this particular case, it's going to be 6 minus 5x is greater than 21. I guess if I follow what I did on the last slide, this would be b. This would be a b and negative b. So I have 6 minus 5x is greater than 21, or 6 minus 5x is less than negative 21. And those would be the two inequalities I would solve. So in this particular case, if I subtract 6, it's going to be 15. Divide by negative 5, I'm going to get x less than negative 3. And in this case, I am going to subtract 6 to be negative 27. And if I divide by negative 5, I'm going to get x greater than 27 over 5. So if I was to write this solution in interval notation, I would have negative infinity up to negative 3, but not including it, union with 27 over 5 to infinity. And if you wanted to even double check this, okay, you could do a number line, because this is going to lead into our last example. And here is negative 3, and here's 27 over 5. If you pick a number like negative 4 and say a number like 6, and we plug them into the original, if I put negative 4 in here, 6 minus 5 times negative 4 is going to be 26, and that is greater than 21. So this region here is valid, which is being illustrated here. And if I plug a 6 in there, I get 6 minus 30, which is going to be a negative 24, and the absolute value is 24, and that too is greater than 21. So therefore, that solution there would also be valid. So this is how you set up an inequality where it's greater than a value. Now, where it gets tricky and where I'm going to stray away from the textbook is when we get questions like the following. Okay, and here's what I'm going to recommend. First of all, we have to list the restriction that x cannot be 4, because 4 would make this undefined. Then I'm going to take the positive branch of the inequality, and I'm going to take the negative branch. And when you take the negative branch, you either negate the numerator or the denominator of your fraction. Now, in this first inequality, I'm going to multiply both sides by x minus 4. I'm going to add 4 over, and I'm going to get x less than 9. Okay, and I'm going to use this 9 on my number line here shortly, and I'll show you what I mean. Over here, I'm going to, again, multiply both sides by x minus 4. If I add 4, I get x is less than negative 1, and I'm going to use negative 1 on the number line as well as 4. So I'm going to show you what I mean of how we're going to utilize the number line to find our solutions. I'm going to put negative 1, 4, and 9 on my number line. 4 was a restriction, 9 and negative 1 were acting like zeros because those were the values I got when I isolated x in my inequality. And now we're going to pick some values in these regions. So negative 2, 0, 5, 10. And I'm going to test in the original question, which was 5 over x minus 4 greater than 1. And let's see if it makes this true. If I put negative 2 in here, I get 5 over negative 2 minus 4 is negative 6. The absolute value is 5, 6, and 5, 6 is not greater than 1, so that does not work. If I put a 0 in for x, I get 5 over negative 4. The absolute value is 5/4. That is greater than 1. If I put a 5 in for x, I get 5 over 1, which is 5. That's greater than x. And if I put a 10 in for x, I get 5 over 6, which is not greater than 1. So I only have 2 intervals that make this inequality true. And because my question is just greater than, I'm going to list negative 1 to 4 as the first interval and 4 to 9 as the second with round brackets. Again, I have to exclude the 4 because 4 makes it undefined. So that's the process to solve more complicated absolute value questions. All right, graphs of absolute value functions. In pre-calc 20, you should have talked a little bit about graphs of absolute functions. Now, on this graph, I'm going to graph the basic function y equals x. And we know that y equals x is just a linear line that looks something like this. Now, the absolute value of x, remember, absolute value, all it does is take your negative values and turns them into positive. So here's all my negative values from my graph of y equals x. And all it does, the absolute value function, is it flips those values to become positive. So if it was negative 4, it becomes positive 4. If it was negative 3, it becomes positive 3. And that is why you get this V-shaped graph for the absolute value of x. So if you were given this graph, y equals x squared plus 2x minus 3, which is shown here, and you wanted to graph the absolute value of this, okay, well, the first thing you're going to do is you're going to look for the x-intercepts. And anything that's below the graph is going to be flipped up. So if I take the vertex right here, which is negative 1, negative 4, that's going to flip up to become negative 1, positive 4, and my graph will look like that. And the parts that are above the x-axis obviously are going to not change. So there would be the graph of the absolute value of x squared plus 2x minus 3. Okay, that ends our assignment or our lesson. So there's your assignment on this section. So good luck with those. And if you have any questions, please check the answers on the website.